Alright, so just a quick review of what we know so far. We know that if I have this function y equals f of x, that the derivative of this function, if it's differentiable, will exist y equals f prime of x. And the derivative function tells us the slope. It's a collection of the slopes of the tangent line at some value x equals a. This function right here, the derivative, is just a function that represents the slopes of the tangent lines. Now if we look at this on a graph, if I have some function which you see in red, then the tangent line at any point x equals a is drawn with that blue line right there. So what we know is that that slope of the tangent line actually changes as we move through the function. And the derivative graph, we can graph the derivative, the height of that derivative graph, the output of the derivative graph, represents the slope of the tangent line. So at this point here, the height of the derivative graph could be something pretty high, like maybe a 3 or a 4, because the slope of that tangent line is a 3 or a 4. Now, we also know that when the derivative is positive, which is the notation that we use, f prime of x is greater than 0, this means that the function is increasing. Okay, so think about this for a second. Let me just back this up. Here, the slope of the blue line is a positive slope. It's increasing from left to right. The slope of the line is positive. So that means the red function is actually increasing. Anywhere that the slope of the tangent line is positive, the function is increasing. When the slope of the negative line, slope of the tangent line turns negative, that means the function is now decreasing. So the slope, or if the derivative is negative, that's an indication that our function is now decreasing. Alright, I get down to the bottom, that's a slope of 0, and now all of a sudden the slope of the tangent line gets positive again, and the function itself is increasing. Now, we're going to take this a step further. We don't want to know just whether the slope of the tangent line changes. We want to know how it changes, how rapidly it changes. And so what we're going to end up doing here is we're going to be taking the derivative of the derivative. So that is called a second derivative. So if we have y equals f prime of x, we're now going to take the second derivative, and we're kind of interested in what will this tell us about the function. What does this say about y equals f of x? If I study the second derivative, how does that tell me something about the original function? That's what we're going to be looking into.